Good morning, students. Today we are going to read the third lecture on the topic of sound in the subject of physics O levels. So concentrate yourself. A very important topic in the topic of sound, that is measuring the speed of the sound, because the numerical questions from this topic frequently come in the paper. So concentrate yourself. We are going to start. And this topic is also very important as far as your paper number 4, that is alternate to practical, is concerned. So concentrate yourself. Measuring the speed of sound. To determine the speed of the sound in air, there are two methods, direct and indirect echo. So first method that we are going to read is the direct method. The apparatus used for this method is one starting pistol, one measuring tape, and one stopwatch. So here is a person and here is a second person. The second person, the observer B, is holding a stopwatch, and the observer A is holding a starting pistol, and there is a open field which will be measured by using the tape. The procedure is observer A and B are positioned at two ends in an open field, must be more than 1 kilometer apart. Measure and record the distance S with the measuring tape. Observer A lifts up his hand slowly, a signal to observer B like this. That will be a signal for the observer B, and then he will fire with his pistol in the air. So look now, observer A lifts up his hand slowly, a signal to observer B, and then fires the starting pistol. Observer B, on seeing the flash of the starting pistol, starts the stopwatch, and on hearing the gunshot stops it, because light travels faster than the sound. So as soon as he will see the flash of the starting pistol, he will start the stopwatch, and when he will hear the gunshot, he will stop the stopwatch. The time interval T is recorded. The speed of the sound V can be calculated by the formula, and here is the formula, that is speed is equal to distance over time. So distance is already measured with the measuring tape, and this time is recorded. So putting values into the formula will give you the speed of the sound. Suggestions for improvement of the experiment. So if you follow these suggestions, the results will be more accurate. Number 1, repeat the experiment and find the average speed of the sound. So repeat the experiment 2 or 3 or 4 times, and then take the average speed of the sound. That will be more closer to the exact value. Number 2, interchanging the positions of the observer A and B when the experiment is repeated. This is to minimize the effect of the direction of the wind. So these are 2 suggestions that will make your answers more accurate. Now we are going to use the second method, that is called indirect or echo method, for measuring the speed of the sound. Stand a measured 50 meters from a large wall, clap or bang sticks together like this, and listen to the echo. Then try to clap in an even rhythm of clap, echo, clap, echo, clap, echo, and up to so on, while a friend times 100 of your clap with the stopwatch. So your friend will start your stopwatch at your first clap and will stop the stopwatch at your 100 clap. So he will record the time for the 100 claps. During the time from one clap to the next clap, the sound would have time to go to the wall and back twice. So this is to remember. So the echo is a distance when the sound waves will go to the wall, and strike back and come back to the ear. So this is the this is the distance traveled by the sound to create an echo. So during the time from one clap to the next clap, the sound would have time to go to the wall and back twice. Friends, start the stopwatch at the first clap and stop at the 100th clap. The time taken T1 is calculated. Calculate the time interval T between successive claps, that will be equal to T1, that is the time for the 100 claps, divided by the 100. So this will be the time that is taken by creating, that is taken for one echo. The speed of the sound V can be calculated by the formula, that is speed is equal to 2 times of the distance over time. Distance is taken 2 times because sound wave is taking 2 distances, that is 50 towards the wall and then 50 meter back to the ear. That's why 2 times of the distance over time is same. So this is the difference in the formula in direct method and indirect method. In direct method, the formula will be speed is equal to distance over time, but in indirect method, in which echo is used, so speed will be equal to 2 times of the distance over time. Sound travels faster through the solids than through gases or liquids, as you can see in the diagram. This is because the molecules are more tightly linked together in a solid. Here is a question that will make your concepts more clear about the indirect method of measuring the speed of the sound. A student stands 100 meters from a large building and claps her hands regularly at the rate of 16 claps every 10 seconds. So the time between the claps will be 10 over 16. That will be 0.625. So this is the time between 2 successive claps. Okay, she hears her each clap coincide exactly with the echo from the clap before. Work out the speed of the sound. So speed is equal to 2 times of the distance over time. Distance is 100 meter. So 2 into 100 over 0.625. So this is the speed of the sound. The next thing that we are going to read in the lecture is resonance. A swing with someone sitting on it has a certain natural frequency of vibrations. If you are asked to push this swing to make it go higher, you will obviously push it each time it comes near you. So you will push like this. That is, the frequency of your pushes will be the same as the natural frequency of the swing. So if your frequency becomes equal to the natural frequency of the swing, so swing will go higher. But if your frequency and the frequency of the swing are not same, so the motion can be stopped even. That is, the frequency of your pushes will be the same as the natural frequency of the swing. Then the swing vibrates with a larger amplitude. This is an example of the resonance. We say that the swing is resonating. If you push at a different frequency, it will not swing as high and you might hurt your hand. Resonance occurs when the applied frequency of the pushes is equal to the natural frequency of the object. The natural frequency of a string can be increased by number 1. So these are the 3 factors which can increase the natural frequency. Number 1, shortening the length. Number 2, increasing the tension. And number 3, using a lighter string. So if these 3 conditions are applied, the natural frequency of the string can be increased. In a similar way, if soldiers march in step over a bridge, they can make the bridge vibrate so much at its natural frequency that it may break. Because if they walk on the bridge with a rhythmic motion, the vibration of the bridge will be increased to much extent that bridge can break. So that's why when the soldiers are going to cross the bridge, they are asked to break their rhythm, because you have seen the soldiers, they walk in very rhythmic way. So onto the bridge, they are asked to break their rhythm. A large bridge in America once fell down because it resonated with vibrations caused by the wind. Have you heard windows or seats on a bus start to rattle as they resonate? So this is another very common experience when the cars or vehicles move at a high speed on highways or motorways. You can see the rattling sound of the glass windows or the things placed into the vehicle, like resonating, they resonate. Okay, when the engine speeds up to a certain frequency, if a singer near a wine glass with a frequency equal to the natural frequency of the glass, it may resonate so strongly that the glass breaks. The next thing that we are going to read in the lecture is the pitch, loudness, and quality of musical notes. The notes from a musical instrument can vary in three ways. Number one, in pitch, number two, in loudness, and number three, in quality of the tone. What do these three things depend on? So here we are going to explain. Number one, the pitch. The pitch, how low or high of a note, depends on the frequency. So frequency is the factor that affects the pitch. A sound wave of higher frequency, shorter wavelength, produce higher note. The next thing that we are going to read is the loudness. The loudness, how soft or loud, depends upon. So look now, some persons can feel the sound of the other persons as very soft, and or we can hear the sound of different creatures, living creatures, that may be experienced as a soft or louder. So look now, the loudness, how soft or loud, depends upon the amplitude of the frequency of the wave. A wave with larger amplitude contains more energy. That's why that is called a louder sound. The loudness of the sound also depends on how much air is made to vibrate. So more the air vibrate, the louder will be the voice. The less the air to vibrate, the softer will be the sound. The next thing that we are going to read is the quality or tone. If a violin and a piano play the same note at the same pitch and same loudness, you can still tell them apart because the notes have a different tone or quality. So you can recognize which sound is of guitar and which sound is of piano. The quality of the sound depends upon the waveform. So in this, waveform depends. Okay, the next thing that we are going to read is the noise. Noise is any sound that you do not like. Once damaged by noise, your ears cannot be mended. The nerves in your cochlea are dead. The chart shows some common noise levels. Okay, here are some noise levels. Okay, the next thing that we are going to read in the lecture is reverberation. Echoes can be nuisance. In an empty room or hall, the reflected sound can take a long time to die away. They come again and again. If you shout in an empty hall, the sound will be echoed again and again because the sound will strike to that wall, will go to that wall, and that will take again and again. So the sound will die away in a longer time in an empty hall. A long reverberation time makes it difficult for you to hear someone speaking. The acoustics of a hall or a factory can be improved by using curtains. So if you use curtains, carpets and soft materials in a place to absorb the sound, the acoustics of the hall can be improved. Concert halls are very carefully designed with absorbers to ensure the right amount of the reverberation. Do you know why good concert halls have walls that are covered either with padded fabrics or soft wood paneling and the floor are richly carpeted? The reason is the purpose of having all these is to absorb sound waves that are produced when musicians perform in the concert halls. Sound tends to bounce around in a hall that has hard floor and walls. This creates echoes. One task of an acoustic designer of the concert hall is to ensure that there is just the right amount of the reverberation for the music to sound good. Our clothes are also good absorber of the sound, so music sounds clearer and sharper in a concert hall that is full than in the same hall when it is empty. So this was the lecture, students. I hope so this will be much interesting and easy for you to understand. So read this lecture again, understand it, learn it and make your notes. Thank you so much.